First of all, I'll give you some overview about the facilities that we have at the University of Sunderland, and then I'll give you a few examples about how to research protection. So, yes, so here you can see we have different printers available, 3D printers, very good range of printers available at the university's level. Here you can see we have F770 and Fortress 450. These are the very, we can say, the powerful printers, and you can see the back sides are very big. So we can prototype big components as well. And we have S5 Pro, which has the capability to print multi-material printing, so which is also very good. We have Combo Lab, 500 meter per second, the very fast printer, so we can make up very small print very quickly. So here you can see. In addition to that, we have you can see Origin 1 printer available. Yeah, this one. We have Origin 1 printer available, which is accelerated lithography, and it can print very fine parts, so which is also very good. We have metal printer available here, and we have composite printer. So all these printers are available in the lab. In addition to that, we have very good material characterization facilities available at the University of Sunderland. So yeah. So how we can help the industry basically. So we can help you out to develop R&D projects. So for example, if you are interested to develop a new product, or you have a system design and you would like to improve it, so you can contact with us, as well as we can help you out for the prototyping. So for example, if you have a design, you have a design in your mind and you would like to test it before the mass production, so you can come to us. Prototype for you, and you can test it. If you are interested in high quality 3D printing on a small scale, so you can contact with us. For example, it's very helpful for dental devices and medical instruments, or any consumer devices, so you can come to us and we can help you out for that. For consultancy, for example, if you really would like to move towards additive manufacturing and would like to move 3D printing in your production line, so you can contact with us and we can help you out to develop feasibility studies or for material selections and all these things. If you really would like to move your business towards sustainability and would like to make a product more eco-friendly, so you can come to us and we can help you out for developing your business for more environment friendly, and it will be helpful for your obviously cost saving, and we can help you out for optimizing all these things. So these are the things that we can do for you guys, so feel free to contact with us. Here I'm going to give you some examples about the research work that we are doing at the University of Sunderland. As I told you earlier, we have a composite printers available, so we are using the composite printer. And what we did here, we use the onyx, which is a mixture of nylon and very fine carbon fibers, and we use it with the continuous carbon fibers all along the parameters of the sample. And these type of samples were very helpful for automotive engineering, for automotive industry. So we tested the sample and we got a very good results. We got very strong sample that could replace metals, especially aluminum. And we got many samples with we can say the high resistance, with very good thermal capability and all these things. So here you can see some of the examples for this. These type of samples, these are the components who are very helpful for the industry, for sports industry, for automotive industry, because it has so much advantage. It can, enhance the span, the durability, decrease maintenance costs, and offer good thermal stability and heat resistance, and it can create a lightweight component, and it could save the fuel costs and running costs and all these things. And obviously with the 3D printer, these type of 3D printer, we can develop a complex design very quickly. So these are the applications for this type of research. Here, this is another project where we really did the what we did here, we tried to optimize the printing parameters that are suitable for different applications. So we started with the roast angles, which is basically the placement of the filament with respect to the bagged 3D printer bag. So we started with the 5-6 roast angles, and then we identify the best out of 5, and then we apply these roast angles, and with the combination of the printer, 3 different printing speeds, and we developed new samples, and we tested them, and out of that research we got some very good set of parameters. And then we applied this research on different materials, and we got very good results. We found out the set of the parameters that we basically explore is very good, and we can get a very good strength out of it, which is more than the manufacturer, the strength that the manufacturer comes. So yeah, so very good result out of it. Another research that we are doing the multi-material additive manufacturing. So we have a printer that would print the multi-material samples as well. Multi-material uses the multi-material at once to create objects. It allows the 3D printer to have different material properties in one component, different materials in one component. It is very, very good. Basically, what was the aim for this research is basically we evaluate multi-material 3D printing, the effectiveness of multi-material 3D printing in promoting sustainability by optimizing the combination of original and recycled material. And we use different combination. We use the different placements, and we use a different percentage of the original and the recycled material. And we found out by combination of recycle with a certain percentage of the recycled material on the original material, we can still get same strength as we can get the original samples, so which is also very good. There are different applications for the polymer printers, so we can use obviously for the rapid prototyping for any component design. So we can use it for prototyping purpose. We can use for customized products, industries such as healthcare, or if we need to develop a component and device according to the client requirements, so we can develop it very easily from the 3D printer. Polymer 3D printer can be used to produce the manufacturing tools, pictures. So here you can see these are the multiple applications for this type of research. In addition to that, in our labs, as I told you earlier, we have metal 3D printers which works with the atomic diffusion technique. Basically, what it does basically, it uses a metal powder bounded with the polymers and is called filament, and we basically filaments are heated and extruded from that, so we can prepare a sample from that. So here you can see we have a line diagram, and then you can see first we need to develop a software modeling, the CAD file, and then we need to transfer into STL file, and then we can give it to the printer as an input, and we need to set the parameters. We need to develop a sample by placing the filament layer by layer, and then we can wash it. We can separate each after the heat treatment. We can get very dense sample, metal sample out of this technique. So which is also very good. So what we did, we tested the sample for residual stresses. As we all know that residual stresses are not good for the metal. It can cause a premature failure during the service. So it is very good to find out either this type of process can produce any adverse effect within the sample or not. So we did this study for that. So we created a sample using 625. We tested it with the destructive technique, which is a method. And we use the mark for printer method for these samples. Here you can see some results. we got a very low residence traffic within the sample, which is very good as compared to other macro additive manufacturing techniques. So again, these are very good results, and it shows that you can create a very good sample for different applications. So yeah, here I'm going to give you some examples about the Arrow project that we just recently did. One of the clients basically he was interested in any sustainable opportunity for vinyl record through 3D printing. So what we did, as we all know that vinyl usually with PVC and PVC are not good. They are non-biodegradable plastic and they are not good for the environment. And obviously it's not very easy to dispose of all these components. So what we did for this project, we explored different alternatives for materials and for manufacturing both point of view. And we tested different 3D printing materials and we used FDM techniques for that, fused deposition modeling. And by using this 3D printing technique, we tested different 5-6 materials and we identified some of them for this particular application. And we suggested that it is very good to explore different additive manufacturing techniques, for example, X-ray lithography. And for this type of application, IP injection molding was a very good option. So we gave them some suggestions from material point of view and for manufacturing point of view, and we will move on from there. Then another project basically the client was interested for sustainable food packaging, and they are interested if we could help them to develop sustainable design for food packaging things, and obviously we need some more options, sustainable options from material point of view as well. So what we did some very good research for them, and we identified some options that they could use as a recycling material that is going to be harmful for the environment. And we also suggested some design as well. In the design, basically, we investigated some alternative design for a compact solution to basically help design the environment with all necessary utilities for children on the go. So we worked with them and we suggested them some design options and some material options for the system. So yeah, so there are some more projects that we are working on, and if you have anything in your mind, so you can contact with us. So feel free to contact us and Chris and other staff. So thank you. All this is already published. So all you can contact.
We now have that.
Good morning. I'm Matt, Director of Intelligent Gels, and you might be looking at the screen going, what is an innovative fish brain? I mean, do people go fishing? Anybody go fishing in the room? No? No idea what I'm going to talk about. Many moons ago, Intelligent Gels was formed as an oil and gas spin-off. But what we've done with Andrew, who's sat in the room from Durham University, is create an innovative fishing bait. I'm going to tell you a bit more about that. So as I said, we are an oil and gas spin-off, so gels have been used in the oil and gas sector since about 1994. But we've also, as a company, tried to think about different ways of doing things. So we've looked at the horticultural market, the food and beverage market, the nuclear sector, all to do special things that really push the boundaries of what existing technologies can do with the use of a gel or a range of nature-based products. I mean, for example, we're probably best known for the work that we're doing in the water sector at the moment. So, for example, we created a gel to remove the source of discoloration in cast iron drinking water pipes, of which there's still 77,000 kilometres of pipe in the UK, and your brown water that you get out of the tap is caused from cast iron. And we created a gel to lift that out of the system, because flushing it with water is really, really inefficient. We like to challenge the way that things have been previously done, and again, we're working with the sewer network, and I'm sure if you read the media, you'll know that the water companies are taking a fairly kind of aggressive approach to trying to solve some of the issues that have been created. So how did the Arrow Innovation Support point us in the right direction? Is we are based on the Net Park in Sedgefield. We are based in the Durham University building. We're also collaborating with Durham University to prevent or prohibit tree roots growing in the sewer network, which will reduce the amount of flooding and increase the resilience of the network. So we've got a relationship with Durham already, and obviously the Arrow Innovation Support is to overcome the hurdles that we have at the moment with the innovative gel fishing bait, and then point us in the right direction to take a new product to market. So if you've used gelatin in cooking, you'll know that it's got a fairly low melting temperature in the 30s. If you're an angler sat in the UK or Europe, the ambient temperatures can be 30, 35, 40, and therefore if you used a food grade gelatin, it would melt into a big sticky pot of something that you can't use to catch fish. So what we needed to do was increase that temperature stability to 60 plus degrees, and also mean that it had amino acids release, which is what fish use as a trigger to eat. So there's also a fake bait market in the UK where there's loads of plastic, silicon, foams, etc., which sit on the lake bed for 20, 30, 40 years, and they're always fishing. So fish can still eat them, even though they're not actually attached to anybody, so it's not great for the fish. And last year, if nobody in the room bought a rod license, then there was more than 1 million other people in the UK did. So it's a fairly big industry. And the Environment Agency showed that freshwater anglers contribute about 1.4 billion to the economy each year. So it's a fairly big sector. We wanted to crack this fishability code and introduce something new to the market. The market's been pretty static for a long time. Fish meal pellets is the go-to for people on commercial waters or waters where people just want to throw in tons and tons of these fish meal pellets, and hopefully the fish will eat them and go home a happy person. So more about the challenge. We worked with the UK and Europe's largest bait company to develop this gel-based fishing bait, which is basically just a cylinder of gel which leaks amino acids, the fish find it attractive, and it biodegrades, and doesn't melt in the sun. However, the fishability is relative to the methods that the angler uses. So that could be a huge range of methods. And again, if nobody fishes, I won't go into the details because you have no idea what I'm talking about. But what we did was using sort of pigments which were readily available in the market already. They were tested and approved for use. And when they've come to be sold into Europe, there is a change to the EU feed additive regulations, which means that the pigments can't be used. So, for example, titanium dioxide is white, it's not on the list, you can't use it. So the bait company came back to us and said, you need to use a natural range of colours. So you will have seen them all in your kitchen. They come from beetroot, cumin, seaweed, etc., etc. However, this was our challenge because they're not very stable and they completely changed the formulation. So, coming to catch the fish and the angler, there are a whole range of colours, red, yellow, orange, white, etc., etc. And to recreate them using natural colours is very, very difficult. And this is where the challenge, and this is where Durham University and Andrea came into play, is we wanted to recreate those colours using the natural dyes, but it didn't work. So we had a product, and now we don't have a product. But the strategic research that Andrea did allowed us to focus on specific formulation modifications. It allowed us to look at the different colour challenges, like from a beetroot, from a curcumin, and unfortunately, when you start with a wide range of colours, everything oxidizes and becomes a shade brown, which is not very attractive to the angler. Maybe not so much the fish, the fish are already brown anyway. So, to sell into Europe, we need to still crack that colour code. So nothing as simple as it seems, and the knock-on effect of using natural colours is across a huge range of industries going forward. So it's quite a big challenge. Our next steps, could we challenge EU regulations? No, we really can't. Are the bait companies challenging the EU regulations? Yes, they are. An example of that is your bog standard tin of sweet corn that you can buy in a supermarket. It's basically sweet corn in a bit of salty water. You can't sell that in Europe from a fishing point of view because it doesn't contain anything that's on the EU feed additive list. So they're now having to recreate a tin of sweet corn in a kind of animal feed, which is completely bizarre. So it's like something that was relatively simple is now becoming mega difficult. So someone somewhere has affected the whole of the industry sector. Can we do further specific research? Yes, we can, and a lot of other people are doing specific research into the use of natural colours. It's not as easy as people think. We need to look at the colour stability and the colour stability for the shelf life, because some of the natural colours don't last too long, and the bait companies want shelf life for 2 years. We can't do that now and again, so there's more specific research that we need to do. And hopefully, Arrow will support us with that. It also created some manufacturing issues as well, because the new formulations have a lot of shape memory, which means that our existing potential manufacturing solutions to literally produce millions and millions and millions of pellets doesn't work. So someone somewhere has changed the regulations that's caused an absolute minefield and a headache. Could we recatch the angler? By that, what I mean is they're used to solid block colours across the full rainbow spectrum. And what they're going to get with the natural colours is something which is dull, not very bright, probably not very attractive on the shelves. So the angler is going to have to change his memory and his approach to using a range of bait to catch fish. So something which was relatively simple to catch a fish is actually now a much bigger minefield for us to take a product to market. Success. Did we have a market-ready product beforehand? Yes. Did we have a market-ready product now? Probably not. But our innovation journey continues, and with the likes of the support from Arrow, we can do these specific pieces of research. So the funding was really important to us, and working, like I say, there's a collaboration with Durham University, helped us focus on a specific piece of research. And as an SME, we couldn't dedicate the resource to the changes that the changes in regulation brought about. So for us, it was really beneficial. I would definitely recommend it to other people. The process that we went through to get the funding was also pretty painless. The process was quick, and I can't thank Andrea enough for the work that she did. And further work would allow us to again try and take a new product to market, which has got a lot of environmental benefits. Like I say, thanks very much to Andrea, and that's obviously quicker than the 20 minutes. But if there's any questions, I'm more than happy to say.
How important was it, you think, being you got on site in Durham University? Was that key before? Is it still key to you guys now?
Certainly the relationship with the university is good because we can tap into levels of academia which we now don't have kind of colour specialists within our business. We, like I said, we were an oil and gas spin-off and we predominantly work with pipeline systems to either remove sediments, remove debris, remove materials that can't be in there. So the fish bait is a direction into a different market. We also work with Durham University on horticulture, so again, which is a massive spin-off away from the oil and gas sector, which is kind of like root and crude, the gel. Working with the university on the horticultural side is the removal of peat and compost from the market means that we are looking at growing seedlings in gel. So again, it doesn't necessarily matter being in a university building, it's just being part of the university, sort of tapping into different parts of their research. That's been the most important. Yeah.
Are you going to get some more help in, obviously this is a stalemate, are you going to get some more help in looking at possibly changing the way your end user will look at the product? I mean, even if it's, it's a brown product, but it's in the right colour packaging that, it's the
yeah, I've been talking to the company about this quite a lot because they're going to have to do it for all of their range of products. But it's not only them; it's there's certainly big players who sell to 30 plus countries in Europe, and they're also working on the use of natural colourings in their existing products. And they, for example, one of them is a particular shade, and when you use a natural colouring, it's black. Historically, the angling market don't buy black products because it sits on the bottom of the lake bed or the river. You can't necessarily see it. So they are, at the moment, they don't really know what to do. Because if you've got to re-educate the angler, that's across Europe, which is obviously the word we want to sell. It's a phenomenal amount of social media marketing or education of the angler that you've caught on a bright yellow fluorescent bait for decades. Now you're going to have something like brown. The market will have to change unless the regulation changes, because there was one of the UK's leading bait companies sells to Lithuania. Their product didn't have all the approved list on the EUP that list, and all of their products had to come out of the country. And this is just a pig bait. It's not harmful to just catch the fish. So the knock-on effect is really quite significant. They keep talking to the regulators, but to see whether there could be changes made. And at the moment, no. Yeah.
Have some form of biological around the actual gel? I don't know how possible that is.
Yeah, I mean, we've looked at alternatives in sort of surface materials, similar to what today, but the product has a specific price point against its non-gel alternatives, so therefore we need to be competitive to that, which at the moment we are, or obviously we were. The potential for the manufacturing issues, we don't know. I mean, the colour doesn't last as long as it should do. You use pigment which was readily available beforehand, and it's used across the loads of industries. So we don't know what the outcome is.
Yeah, I do actually.
Oh, you do? Yeah.
I do use Power Beer.
Yeah.
So Power Beer, look, really happy that one.
Yeah.
It's great colour, glitter.
Yeah.
It's attractive to me, but it does work.
So you do more trout fishing?
More lakes,
Like,
lakes, trout, that sort of fishing.
yeah.
But I would swap it at the drop of a hat if I could win. Even if it was brown, the colour really wouldn't matter.
Sorry. Fish do currently see different colours, and there's loads of fish type related things like the air pressure, the water temperature, the colour of the water, like the fish trying to get. whole range of stuff. Why there's no kind of, I don't think there will ever be a magic bait, because I worked with Nash many years ago, and they have a lake where they predominantly feed carp, and because they're no fish, you know, each one of them practically goes own name, and they fed yellow bait on one side and red bait on the other, and some parts of the year they would only eat yellow, then towards the winter they would only eat red.
So garlic and orange will make it either.
Yeah, there's a whole range of flavours. So the flavours come back to basically this amino acid release, which obviously does fish triggers. So there's a chemical in pineapple which is attractive to fish. But if you overdose the flavour, it actually turns the fish hot, too strong. Yeah. Yeah, so the mackerel is foil, which is ridiculous when you think about it. It's got no benefit to fish whatsoever. Whereas the bait that we've created is biodegradable, but it does contain both, you know, the natural fish meal pellets that are high protein. So the bigger sort of complexes will get you to use their own pellets because it's actually good for the fish, and the low grade stuff actually creates problems with water quality. Therefore, the fish health declines.
Thank you.
Thank you very much for the questions, because obviously, but hopefully you've been educated into more about the problems that we've got based on the changes to EU legislation. Thank you very much.
I just realised that back to questions for Nida.
Yeah.
Presentation. So, do you want to come out?
Yeah.
Can you all remember what Nida was talking about and what you do? So, were there any issues from that? Any questions or any observations or anything that you'd like to? Yes.
One question from my side. So, in terms of longevity testing new materials that you provide statistics, you do it like lifetime testing to see environmental effects and to is that something that's in place now? So do you do repeat tests after a year to prove that it's still as strong as it was when you did the analysis?
Yeah, as I told you, it's the atomic diffusion. So what we are using the metal powder, and metal powder basically they are combined with the polymers. So like FDN techniques we are using for this. So okay, you can see the metal powder bounded with the polymers in this form, and what happened? The filaments are heated and extruded and onto the moving pad. So we got the sample with the you can say the polymers, the black powder inside the polymers, and then we washed it, and since like after the heat treatment we got it, the solid parts. This is not the base. We are not using the polymer.
So is it not that? Like obviously you made a certain
Yeah, with the poly and all these technologies. These are actually so these are the mark forged ink printers. So if you Google it, Mark X printer, so you can find out. This works with the electronic diffusion.
Yes, Julie.
You've got, you showed a sample of multi-polymer
Yeah.
we only have in the UK twin or triple shot, so where's the purpose for it? So you can't actually take it from prototyping into production. So what was the thinking behind having multi-polymers in a particular?
Thinking behind basically, I think we can produce a more realistic one in terms of if we would like to combine the two materials. So, for example, if we would like to combine two materials in a theory or areas, so we can expose some application about it, but with the commercial point of view, there is an opportunity we can combine. Okay, so now we need to see what are the further applications about it. Definitely, we can use the multicolor ones, so same material with different colors. For example, in the photos you can see, So if we need a more elastic material within the two things, so we can use a more elastic one and the rigid on top and bottom. So these type of combination we can try. We have an opportunity over company. So I can explore further application about it. So how we can do it. Just not for the color, but this is we can combine these material properties for also enhance. So yeah, so we can use it for the application.
It's an interesting process.
Yeah.
But from a sustainability point of view, you can't actually put that many materials together because you can't separate them.
Yeah. We can't separate them, and it is very difficult to combine two materials as well because of the banking point.
Yeah.
It's easy, but it's not that easy. Yeah, but surely the work that I did what I did, I used the original material with the recycled material. So both materials are same, but one is a recycled one and another. So it's not very difficult to combine them because the main base properties are the same. So the idea for this research is either we can if we use some portion of the original material and some portion of the recycled material, so what property we can get? So in our research, we are combining them with a particular ratio, so we can get the similar property that we have the original one. So what we did, for example, 30% we use the recycled one. So here we have a sustainability factor over there. So we can combine two materials, one is the recycled, one is the original. So in terms we can save some sort of original material.
Hopefully all our schools are around the work, so you will have to talk to them together and please do. Should we have a little break? I think the coffee has been recharged, so don't leave. Go grab a coffee if you need to. Facilities are just around that corner, upstairs, there's some accessible places to the door, and then we'll start again in about, let's say, 10 minutes. Okay? Thank you.